Hello friends, today we will see minimal polynomial and minimal equation of a matrix. What is a minimal polynomial and what is minimal equation of a given matrix? So for that we will see some useful definitions that we are having here. Let f of x be a polynomial in x and a be any square matrix of order n. Okay, if f of a is equal to 0, that means instead of writing x we will use a, and for that the value in RHS becomes 0, then we say that f of x annihilates the matrix A. Suppose we have a polynomial f of x is equal to x square plus 2x plus 3, then in that polynomial if we use x is equal to a, that is f of a is equal to a square plus 3a plus 2 equal to 0, then we can say that f of x annihilates a. So in the same way, we know that by Cayley-Hamilton theorem every square matrix satisfies its characteristic equation. Okay, hence the characteristic polynomial of a matrix A annihilates A. Okay, so characteristic equation is satisfied by every square matrix. That means characteristic polynomial of that matrix annihilates the matrix. Okay, so if we are going to illustrate this one, so I would like to write here, if a is equal to 1 to minus 2 minus 1 3 0 0 minus 2 1, then the characteristic polynomial is, here I am writing x, that means determinant of a minus xi. So we will use here lambda also, no problem, a minus lambda identity. Okay, so this is also a characteristic polynomial, don't confuse in lambda and x. So these are the scalars only. So f of x is equal to x cube minus 5x square plus 9x minus 1. So this is the characteristic polynomial. So characteristic polynomial is obtained from given matrix by simply writing x cube minus sum of the diagonal elements into x square. So sum of diagonal elements is 1 plus 3 plus 1 is 5, so 5x square plus sum of the diagonal minors into x. So sum of the diagonal minors are 1, so 3 plus 1 4 and then 4, so that is 9x minus determinant of a given matrix is 1. So if we put x is equal to a in a form, then f of a is equal to a cube minus 5a square plus 9a minus 1. But by Cayley-Hamilton theorem, what it says, a cube minus 5a square plus 9a minus identity is equal to 0. Therefore f of a is equal to 0. This proves that f of x annihilates a given matrix A. Okay, so this is about the annihilation of a given matrix. Now we will see monic polynomial. What is monic polynomial here? Monic polynomial in which a polynomial x in which the coefficient of highest power of x is unity. Okay, here I would like to write some polynomial. Suppose x cube plus x equal to 0. So this is the equation, and we are going to see only polynomial. So let me write here x cube minus x square plus 11. So suppose this one is a polynomial in which one is the highest power of x? 3. So coefficient of x cube is 1 here. Okay, so this is the monic polynomial. Okay, and I would also like to do one thing, 2x cube minus 9x square. So suppose this one is in a monic, this one is also polynomial in x. Now check highest power of x, which is highest power 3. So x cube, check the coefficient of x cube, which is 2, not equal to 1. So this is not monic polynomial. So monic polynomial is nothing but a coefficient of highest power of x is unity. Okay, so this is the thing here we have to understood. For example, I have written here x cube minus x square plus 5x minus 11 is monic polynomial because coefficient of x cube is 1. But 2x cube minus 4x square plus 6x minus 2 is not monic polynomial because coefficient of x cube is not equal to 1. Okay. Now we will see the second definition, that is a minimal polynomial of matrix. The monic polynomial of lowest degree that annihilates a matrix A is called minimal polynomial of A. The monic polynomial of lowest degree that annihilates a matrix A is called minimal polynomial of A. Okay. Now further, if f of x is a minimal polynomial of A, then the degree of f of x is equal to 0 is called, sorry, what I am saying here. Further, if f of x is a minimal polynomial of A, then the equation f of x is equal to 0 is called the minimal equation of matrix A. Okay. Now we should note some things. If a matrix A is of order n, then its characteristic polynomial is of degree n. The characteristic polynomial of A is A annihilates A. Second thing is, we should note a matrix, first thing is, if a matrix is of order n, then its characteristic polynomial is of degree n. Okay. Second thing is, the characteristic polynomial of A annihilates A. So combining these two, we should have the degree of minimal polynomial of A cannot be greater than n. That means n is order of matrix. That means a degree of minimal polynomial is either equal to order of matrix or less than order of matrix. Now we will see derogatory and non-derogatory matrices. And square matrix of order n is said to be derogatory or non-derogatory according as the degree of its minimal equation is less than or equal to n. Okay, simply we have to distinguish these two definitions. First, note that an square matrix of order n is said to be derogatory if the degree of its minimal polynomial or equation is less than n, then we can say that the matrix is derogatory. And for non-derogatory matrix, an square matrix of order n is said to be non-derogatory if the degree of its minimal polynomial is exactly equal to n. Okay, in that case we should call it as non-derogatory matrix. Now we will note some more things. Each eigenvalue of square matrix is a root of minimal equation of square matrix. Okay. So second one, eigenvalues of square matrix A are distinct, then A is non-derogatory. If all the eigenvalues of a square matrix are distinct, then matrix is non-derogatory. And suppose lambda 1, lambda 2, lambda 3 are the distinct eigenvalues, then its minimal equation is represented simply by this product. Okay. Now we will see the procedure. What is the exact procedure to determine whether A is a derogatory or non-derogatory? First thing we should note here, first find the characteristic equation of A and then solve it. If if eigenvalues lambda 1, lambda 2 and lambda 3 are distinct, then A is non-derogatory. Third thing is that if lambda 1 equal to lambda 2, that means first two eigenvalues are same and third one is distinct, then find whether the equation x minus lambda 1 into x minus lambda 3 equal to 0 satisfied by A. If yes, then A is derogatory. If no, then A is non-derogatory. Now we see the fourth point. If lambda 1 equal to lambda 2 equal to lambda 3, Okay, then find whether the equation x minus lambda 1 equal to 0 is satisfied by A. If yes, then A is derogatory, otherwise non-derogatory. Are you getting my point? Now let's see the question here. Question is, show that the given matrix A having entries is a derogatory. So this question is asked in Mumbai University examination for the branches civil, mechanical and instrumentation in the past few years, and we are going to solve this question. Okay, in the solution we will follow the procedure that we have seen here. So first point is find the characteristic equation of A and solve it. So characteristic equation of A is this one, determinant of A minus lambda I is equal to 0. Now we are going to solve it. That means if a characteristic equation is represented by lambda cube minus sum of the diagonal elements, and that will be 5 lambda square, sum of the diagonal elements is 8 and that one be 8 lambda minus determinant, and determinant is 4. Therefore a characteristic equation is a lambda cube minus 5 lambda square plus 8 lambda minus 4 equal to 0. So if we solve this one for the factoring method or synthetic division or whatever useful method, lambda minus 2 into lambda square minus 3 lambda plus 2 is equal to 0. So this is the further factorization. Now we will say lambda minus 2 into lambda minus 2 into lambda minus 1 equal to 0. That means 1 comma 2 comma 2 are the roots of above characteristic equation. Okay, and we know that roots of characteristic equation are nothing but the eigenvalues. So now let's find a minimal polynomial of A. Okay, so this is one part, and now we are going to find the minimal polynomial. So procedure to find minimal polynomial is that here we have first two eigenvalues are same and third one is distinct. So if f of x is a minimal polynomial of A, then x minus 1 and x minus 2 are the factors of f of x. Okay, now let's check the polynomial x minus 2 into x minus 1 equal to, so product of these two factors is nothing but x square minus 2x plus 3, x square minus 3x plus 2 is annihilates. Okay, for this purpose we have to note a square. So a square is calculated for this x square. For this x we should use a. For this 2 we should use 2 into identity. So a square means product of a with a, that means a square. So if we multiply a with a, then we should have 13 minus 18 minus 18 minus 3 10 6, then 9 minus 18 minus 14. Therefore a square minus 3a plus 2 identity equal to 13. आता हे जे आहे ते आपल्याला पुढे लिहिता येईल विस्तृत पद्धतीनं. a square minus 3a plus 2i is equal to 13 minus 18 minus 18 minus 3 10 6 9 minus 18 minus 14 minus 3 times 3 times a, that means 15 minus 18 minus 18 minus 3 12 6 9 minus 18 minus 12 plus 2 times identity is nothing but 2 0 0 0 2 0 0 0 0. Now we have to calculate 13 minus 15, that is minus 2 plus 2 is equal to 0 here. Okay, minus 18 minus minus plus 18 0, here it is 0. Now minus 18 minus minus 18, that is plus 18, so 0, here 0. So all the entries in the first row become 0. In the second row minus 3, here minus minus plus 3 0, here 10 minus 12 minus 2 plus 2 0, here 0, here 6 minus 6 0 0 here. So all the entries in the second row 0. Now the third, see here, for the third, here it is 9 minus minus 9, sorry minus 9, which is 0. Now minus 18, here minus and here minus plus, so minus 18 plus 18 0, here we 0, so here we have 0. Minus 14 minus minus 12, that is plus 12, minus 14 plus 12 is minus 2, and here it is plus 2 becomes 0. So all the entries in the RHS are 0. Hence a square minus 3a plus 2i is equal to 0. That means f of x is equal to x square minus 3x plus 2 annihilates a. This proves f of x is a monic polynomial of lowest degree that annihilates a. Hence, by definition, we can say that f of x is minimal polynomial of a, and we have degree of minimal polynomial is 2 here, okay, is 2 here. So degree of f of x is less than 3. 3 is nothing but order of a, therefore a is derogatory according to definition. Are you getting my point? Okay, thank you.